Hello po, magandang Tuesday sa ating lahat, especially sa ating mga guro at mga students at mga cooking Pilsay hobbers. It's Tuesday na naman po at welcome po sa isa na namang exciting na chemistry discussion dito lamang sa Chemistry Tidbits, bite-sized chemistry content. Sa video po na ito, yung pag-uusapan po natin ngayon is all about dimensional analysis and unit conversion. Ano nga ba yung dimensional analysis? Paano nga ba ito ginagawa sa larangan ng chemistry? Bakit nga ba natin kailangan establish yung basics foundation ng dimensional analysis pag nag-aaral tayo ng chemistry? Yan yung mga tatalakayin natin ngayon, kasama na rin yung mga different examples. Now, sa lecture video na ito, magsisimula muna tayo ng review ng unit prefixes at conversion factors. Then, it's going to be followed by discussion on dimensional analysis, and then step-by-step examples, at saka more exercises. Now, let us first have a review on unit prefixes. So, ano nga ba yung unit prefixes? Unit prefixes are put before the basic unit of measurement and specifies or indicate multiples or submultiples of that unit. Each prefix has a unique symbol and a corresponding factor. So as you can see here in the picture, some of the most used unit prefixes that we are familiar with are kilo, milli, micro, nano. In the case of milli, you have a factor of 10 raised to negative 3. In micro, 10 raised to negative 6. In nano, 10 raised to negative 9. And so on and so forth. A review as well for conversion factors. Say we want to convert a meter to feet or feet to meter. And we know that there is 3.3 feet in 1 meter. So yung gagamitin natin na conversion factors is 3.3 feet over 1 meter or 1 meter over 3.3 feet. Depende kung ano yung given sa problem at kung ano yung hinihingi sa problem. The same principle applies in other unit of measurements, like say in pressure. Say you are going to convert from atmospheres to milliliters of mercury and vice versa. So yung mga gagamitin mo na conversion factor is either this or this. So now yung pag-uusapan natin is dimensional analysis. Dimensional analysis is also called factor label method or unit factor method. It is the conversion between an amount of one unit to the corresponding amount in a desired unit using various conversion factors. Yung dimensional analysis is na-a-apply siya not just in chemistry, but also in other sciences like physics. Funnily enough, ginagamit natin yung dimensional analysis hindi lang talaga in formal science, but ginagamit natin to in our daily lives. We just don't know na ginagamit pala natin to. Let's say for example, here's a more relatable example. How many pieces of pizza do I have? So, yung problem is that if may dalawa kang pizza, ilan lahat ng slices ng pizza if each pizza has 12 slices? So, gagamitan mo ng dimensional analysis, 2 pizzas times there are 12 slices of pizza in one pizza, evaluate the equation, and then you get 24 slices. Dimensional analysis is a very essential tool in chemistry, especially when doing stoichiometric calculations. That's why a good grasp of dimensional analysis is needed to learning chemistry and analytical chemistry. Now, let us move on to the step-by-step examples of dimensional analysis. Now, we can do dimensional analysis in 3 steps. Step 1. Remember WAG. What is asked and what is given. Step 2. Use appropriate conversion factor, direct, or series of unit factors. Step 3. Compute and observe significant figures. Let us now move on to our first example. So for example number 1, same basic unit, different prefix. Convert 50.0 mil to liters. So let's approach the problem in step-by-step manner. So yung step 1, remember WAG. ano yung hinihingi sa problem, ano yung binigay sa problem. So the direction of resolution is from milliliters to liters. Step 2, use appropriate conversion factor. Ano nga ba yung relation ng milliliters at liters? So in 1 liter, we can use this conversion factor that in 1 liter, there is 1,000 milliliters. So step 3, compute and observe significant figures. So evaluate the equation, cancel milliliters, you will get 0.0500 liters, which is reported in 3 significant figures. For example number 2 naman, conversion from one unit to another. How many moles of sodium chloride are there in 30.00 kilograms of sodium chloride? Step 1, remember WAG. The direction of the problem is from kilograms to moles. Step 2, use appropriate conversion. How are we going to convert kilograms to moles? So we can first convert it to grams and convert it to moles using this conversion factors. 1,000 grams over 1 kilogram times 1 mole over 58.44 grams. The 58.44 grams, ikinuha natin to by adding the atomic mass of sodium and chlorine. Step number 3, compute and observe significant figures. So evaluating the equation, doing the necessary cancellation, kilograms, kilograms, grams, grams, you will be left with moles of sodium chloride. Evaluating the equation, you will get 513.3 moles of sodium chloride, which is reported in 4 significant figures. Now for example number 3, conversion involving derived units, convert 14.5 cubic meters to liters. Step 1, the direction of the problem is cubic meters to liters. Step 2, use appropriate conversion factors, which is in this case, yung gagamitin natin is a series of factors. So from cubic meters, i-convert natin siya into cubic centimeters, to milliliters, and to liters. Para mas madali natin i-approach yung conversion ng cubic meters to cubic centimeters, alam naman natin that there is 100 centimeter in 1 meter. So we can just use that conversion factor and then cube the numerator and the denominator. Then add 1 mil over 1 cubic centimeter and then 1 liter over 1,000 milliliters. In step 3, evaluate the equation, do the necessary cancellation, and then you will get 14,500 liters or 1.45 times 10 raised to 4 liters, reported in 3 significant figures. Now for the last example, example number 4, conversion involving 2 units of measurement. What is the density of mercury, 13.6 grams cubic centimeter, in units of kilograms per cubic meter? So step 1, remember WAG. So the direction of the problem would be from grams per cubic centimeter to kilograms per cubic meter. Step 2, ano nga ba yung appropriate conversion factors na gagamitin natin? So, since we have grams per cubic centimeter yung given, pili muna tayo. Either magsisimula tayo sa grams or magsisimula tayo sa cubic centimeter. So, in this case, inuna natin yung cubic centimeter. So, just like in example number 3, we used first the conversion of 1 meter to centimeter and then cube the denominator and the numerator to get the cubic centimeter. So, na-convert na natin yung cubic centimeter natin into cubic meter. Yung i-convert na lang natin is in yung grams. So, gagamit na naman tayo ng isa pang conversion factor to convert grams into kilograms. So, evaluate the equation in step 3, do the necessary cancellation of units, and then you will get 1.36 times 10 raised to 4 kilograms per cubic meters, reported in 3 significant figures as required in the problem. So that ends our examples. If you're interested in more exercises about dimensional analysis and unit conversion in chemistry, you may scan the QR code or log in to the link to get the worksheet with exercises. So that would be all po. I am Jason Alcano, a chemistry intern here at PhilSciOb. Thank you for tuning in.